We are on the cusp of a new era of space exploration, one that promises to be as transformative as the Apollo missions. This time, however, our sights are set not just on visiting the moon but on staying there. The moon, once a distant object of wonder, is now viewed as a potential resource hub and a stepping stone to further exploration. Imagine living on the moon. Picture lunar cities bathed in the soft glow of Earthlight. The cost of establishing a permanent human presence on the moon is astronomical, requiring technological innovation and unprecedented international collaboration. Transporting materials from Earth to the moon is incredibly expensive. Therefore, the key to sustainable lunar habitation lies in utilizing resources found directly on the moon. This concept, known as in-situ resource utilization, or ISRU, is at the heart of the current race for lunar resources. Water ice, believed to be trapped in permanently shadowed craters at the lunar poles, can be broken down into hydrogen and oxygen, providing both breathable air and rocket fuel. As we venture further into space, we are faced with a critical question: who owns the moon? The 1967 Outer Space Treaty states that outer space, including the moon, is not subject to national appropriation by claim of sovereignty. However, the treaty is silent on the issue of commercial exploitation of celestial resources. This ambiguity has led to differing interpretations and growing concerns about a potential free-for-all on the moon. The 1979 Moon Agreement designates the moon and its resources as the common heritage of mankind, and calls for an international regime to govern their exploitation. However, the Moon Agreement has been ratified by only a handful of countries, none of which are major spacefaring nations. The legal ambiguity surrounding lunar resources has fueled a race among nations and private companies to establish a foothold on the moon. The United States, through its Artemis program, aims to return humans to the moon and establish a sustainable presence there. In 2020, the U.S. announced the Artemis Accords, a set of principles for the peaceful and cooperative exploration of space. While the accords emphasize collaboration, they also assert the right of nations to extract and utilize space resources, a position that has drawn criticism from some countries. Similarly, other space powers like China and Russia are pursuing ambitious lunar programs with the goal of resource exploration and potential utilization. International cooperation and a commitment to sustainability are essential for ensuring that the moon's resources benefit all of humanity. The race to the moon is no longer solely a government endeavor. Private companies are playing an increasingly prominent role, driven by the potential commercial opportunities of space exploration and resource extraction. Companies like SpaceX, Blue Origin, and Rocket Lab are developing innovative technologies and lowering the cost of access to space. SpaceX, with its Starship program, aims to create a fully reusable transportation system capable of carrying humans and cargo to the moon and Mars. Blue Origin is developing its New Glenn rocket and a lunar lander called Blue Moon, designed to deliver payloads and eventually humans to the lunar surface. This commercial involvement injects much-needed innovation and capital into the space industry, accelerating the pace of technological development. Striking a balance between encouraging private investment and ensuring responsible and equitable access to space resources will be crucial for the long-term sustainability of lunar exploration. Utilizing lunar resources for construction is key to establishing a permanent human presence on the moon. Lunar regolith, the fine, powdery dust covering the moon's surface, holds immense potential as a building material. One promising technology is sintering, where regolith is heated to high temperatures using concentrated sunlight or lasers, fusing it into solid blocks or bricks. These lunar bricks can then be used to construct landing pads, roads, and even habitats, providing protection from radiation, micrometeoroids, and extreme temperatures. Another promising approach is 3D printing, which can create complex structures layer by layer using lunar regolith as the building material. Water ice, found in permanently shadowed craters at the lunar poles, is another crucial resource for lunar construction. The race for lunar resources holds both immense promise and potential peril for humanity's future. On the one hand, lunar mining could provide valuable resources to support a growing global population, alleviate resource depletion on Earth, and fuel further space exploration. Helium-3, a rare isotope found in lunar regolith, has the potential to revolutionize energy production through fusion power. offering a clean and nearly limitless source of energy. The moon could also become a hub for manufacturing and scientific research, taking advantage of its unique environment and resources. However, lunar mining also raises concerns about environmental damage and the potential for conflict. Unregulated mining activities could disrupt the pristine lunar environment, create space debris, and damage sites of scientific or cultural significance. International cooperation, ethical guidelines, and a commitment to sustainability are essential for ensuring that lunar resources are utilized responsibly and for the benefit of all humankind.